Okay, let's take a look at calculating or explaining how the resistance in a length of wire can change. The formula in your notes tells you that resistance is the resistivity, and the resistivity is just a number given to every type of metal. Think of it like a mu for a surface, like we did in friction. So you have your resistivity, you multiply it by the length of the wire, and then you divide by the area, the cross-sectional area of the wire. But we need to remember that the wire is a cylinder. So its cross-sectional area is a circle, so therefore the cross-sectional area is pi r squared. So we can go ahead and expand the formula from this, expanding the area to pi r squared. So if we go ahead and take a look at the questions on the bottom of your section in resistance, it tells you that you have a copper wire, and you're told that this copper wire has a resistivity of 1.7 times 10 to the negative 8 ohm meters. It goes on to say in part 1 of the question, what is the resistance of a 1 meter length of copper wire? So we know that L is now 1 meter. It also gives me the diameter. The diameter is 1 millimeter. So we can go ahead and change that to the radius. So the radius is going to be 0.5 millimeters, but we can't use millimeters. So I'm going to go ahead and change that to meters. So we now have all the data, so we can simply go ahead and just plug and chug. Resistance equals the resistivity, 1.7 times 10 to the negative 8, multiplied by the length of your wire, divided by the cross-sectional area, which is pi r squared. And when I go ahead and put that all into the calculator, we get a resistance of 0.022 ohms. So yes, there will be questions like that on your quiz. The second part of your notes asks you to go ahead and start thinking about what happens if we change some of the variables. So it's telling me that I've got to go ahead and change my length to 2 meters. Okay, so in other words, what we're doing is we are doubling L. So the formula says R equals resistivity times the L over the pi r squared. So in the past, and we will continue to do so, the resistivity stays 1. We are doubling the length, so that becomes a 2. The pi stays the same. The radius stays the same. So all of that goes ahead and gives me a factor of 2. So therefore, the new resistance is going to be 2 times the 0.022 ohms that we calculated in the previous question. So the new answer is going to be 0.044 ohms. So that's how we would go ahead and do that one. So then we come on to the third one. And the third one is telling us this time if we're doubling the diameter. So if we double diameter, that means we double the resistance and we double the radius. Therefore, we can turn around and using the same formula, we can say the resistivity stays the same, the length stays the same, the pi stays the same, but we are doubling the radius. But remember, the radius gets squared. Therefore, I've now got a factor of 1/4. So we can turn around and say the new resistance is going to be a quarter of the original. So we can turn around and we can say that it's going to be 0.0055 ohms. If we go ahead and take a look over the page, we have another practice problem on resistivity. And you can see there's a whole list of all of those resistivity numbers for all the different metals and also some other materials. So the question here says, a physics student compares two lengths of copper wire. The first wire has a radius of R and a length L. And the second wire, so I'm just going to take some notes, you know how I like to write it down. So the first wire has a radius of R and a length of L. And then my second wire, it's got a radius of 2R and then it's got a length of 3L. So the first question says, what length of wire has the greatest resistivity? Well, remember, resistivity comes from the material. The story tells me that the material is copper. Okay, therefore, it's the same. Both wires have the same resistivity, which is equal to that 1.7 times 10 to the negative 8 ohm meters. So question number 2 says, which length of wire has the greatest resistance? So we can go ahead and we can say, if I look at the first, we can say that the resistance is going to be that resistivity times its length times the pi r squared. The second is going to go ahead and it's going to still have the same resistivity, but it's got 3 times the length and it's also got a radius of 2r, so that's going to go ahead and be 2r, but all of that's going to be squared. So we can turn around and take a look at it and say that has a factor of 3/4 of the resistance. So it says, which length of wire has the greatest resistance? Okay, therefore, the first wire has the greatest resistance. Okay, so just going over that again because the paper wasn't visible. The first wire, we were told this was the setup. The second wire, we said had 3 times the length. It had double the resistance, but we have to go ahead and square that. So looking at the numbers going on here, I have 3/4 of what the first one is. So the first wire has greatest resistance.